Thank you. Dear colleagues, dear students, let's start our meeting. And today we have presentation of Камилла Бахтиева. Камилла, the screen is yours.
Yes, good evening. Can you see my screen?
Yeah.
Yes, we see.
So the topic of my research is financial factors of the timing of retirement before and after COVID-19. And my supervisor is Елена Станиславовна Катырна. I will briefly start with the motivation and the research question, then proceed to the literature review and how this study is placed in the existing literature. Then I will discuss the data and methodology I have used, some of the results, and the limitations of the study, as well as some further work to be done. So, as we know, recent years have showed some negative demographic trends, including, for example, aging of population, as well as population decline, and the changes in the population composition, which have significantly affected the labor market situations overall, and majorly the labor market participation of older people. And as we know, many countries have introduced pension reforms in their retirement systems so as to follow these trends and to increase the minimum retirement age, after which people can be entitled for social security benefits. On the one side, this is some governmental restriction, and on the other side, what are the factors which are based on individuals' specific preferences? I wanted to look at this side of the retirement timing and focus more on the financial factors of the timing of the retirement. And also, I wanted to study whether some exogenous shocks, such as recent pandemic caused by the spread of COVID-19, have altered the relative importance of these factors for Russian individuals. I will start from the theoretical perspective, which can be seen in the literature regarding the retirement timing. And majorly, the retirement timing is studied through the so-called life cycle theory, where agents simply maximize their lifetime utility, and they have basically two periods. The first one in which they are employed, and the second in which they are retired, with R being the retirement timing and the variable of choice, which is chosen through the maximization of utility based on individual preferences on consumption and leisure. For example, I have looked at two papers which consider this kind of model, and they mostly coincide in the conclusion on the factors of the retirement timing. For example, in the first paper, agent's optimal retirement timing is mostly affected by the so-called replacement rate, which is the fraction of pension benefits by the wage income, which is earned by the individual while he or she is employed. And the main conclusion is that higher replacement rate is associated with earlier retirement or lower R. And similarly, in other work by Kingston, the optimal retirement timing, which is, as we know from microeconomics, for the models in which we maximize utilities, the variables of choice are such that the marginal benefits are equal to marginal costs. So here, the optimal R is such that utility from continuing work is equal to the utility from the foregone leisure. Given the similar setting, Kingston concludes that there are a number of individual characteristics which define the optimal retirement timing. Particularly, there are factors which can induce it, so that to make R lower. For example, the high level of accumulated assets throughout the years, low wages, high value of leisure, as well as short lifespan. So this theoretical perspective gives us some insights on how different factors could affect the retirement timing for different individuals. The next and most important part was the study on the empirical works, which study necessarily the factors which are seen in the data for different individuals from mostly Western countries, including UK, countries from the European Union, and US. All these factors can be divided into three main groups, which are socio-demographic factors, which are often used as control variables. As you can see here, most papers use such variables as age, gender, health condition, race, education, marital status, also often the occupation status of the spouse, job experience, sometimes housing equity and income, for example. Also, there are financial factors, which are the focus of my study. And in these papers, they are also the variables of interest for the authors. And they mainly concern the so-called pension benefits or social security benefits, as well as, for example, some papers consider the option value of retirement, which is not observed in the data, unlike the pension benefits or retirement wealth, but is obtained through microeconomic models. There are many papers which discuss different types of factors and conclude on whether socio-demographic or financial or other factors induce retirement or postpone it. Specifically, some papers find that usually females retire earlier than men. Also, people with poorer health condition retire earlier than those who have who are healthier. Also, some kind of occupation differences can affect the timing of the retirement, as well as some macroeconomic factors, as is studied by Gorodnichenko, Song, and Stolярov, such as unemployment and inflation. So basically, there are many empirical papers which study a number of categories of factors which can affect the retirement timing, including social, demographic, and financial. And the last group, financial factors, is the group in which I focus mostly in this study. And last but not least, the methodological perspective on studying the retirement timing. In some papers, which I have mentioned in the literature review, there are binary choice models used as the empirical strategy. However, here authors mainly concern the research question of which factors affect whether the person is retired earlier or retired later. So, for example, if a person which is older than the minimum retirement age is retired or not, and there are factors which can affect this retirement status. And another approach is the so-called survival analysis, in which there is an event of interest, which is also often called as a failure event of some process. In such case, it is the employment. And the event of interest here is the transition from employment to retirement, which we consider as the full absence of working hours or reporting being retired as the primary occupation for an individual. There is also a theoretical fundamental background on this approach. The hazard rate, the so-called hazard rate, is the instantaneous rate of transitioning from one condition to another. So here of transitioning to retirement in some period if a person has not retired yet. And often the hazard rate is described as a function of a number of characteristics, individuals, which may be constant or time varying. And the functional expressions for this big data of x1 or big data of xt2 can be, for example, exponential or log logistic, and etc. There are also some works which consider the most recent changes and specifically the effects of COVID-19 on retirement. I have briefly concluded 3 papers here, which consider the effects of COVID-19 in the US and in Russian economy. 2 papers on the effect of COVID-19 on the US individuals conclude that the effect was mostly inducing retirement because people started being more concerned on their health issues, as well as the labor demand side has plummeted due to recession, which was tied with the COVID, with the crisis associated with the pandemic. And on the contrary, for Russian economy, in most recent paper by Kapelushnikov, also analyzed the effect of COVID-19 and the changes in the labor market situation in recent years. And author points that mostly the changes in recent years were associated with the pension reform, since mostly we can see in the data that people started retire later, which can be thought of as the impact of the increasing retirement benefits eligibility age. However, COVID-19 has affected mostly employed side of the population, since it affected the ways of employment, particularly, for example, the remote working. If we talk about the place in the existing literature, I think that mostly it is the hypothesis which we can assume based on the literature review and on the findings of other papers of the effects of different financial factors on the timing of retirement. So I have chosen 4 main factors, which are replacement rate, income level, having outstanding debt, and owning a house. And I assume that replacement rate and house ownership should have a positive impact on the hazard to retire, so they should induce retirement, while income level and having outstanding debt should have negative impact. Also, for all these factors, I assume, given that the COVID-19, on the example of works on the impact of COVID-19 in the US economy, it should have shifted the focus in the retirement decisions and decreased the impact of financial factors and maybe shift the focus to health factors. Also, my empirical strategy is the survival analysis, specifically Cox proportional hazard regressions, with 2 different models which include or not include different control variables and are estimated either on full or in subsamples. I will talk about the modeling a bit later. So diving into the data, I have used the Russian longitudinal monitoring survey for the waves 26 to 30, which cover years from 2017 to 2021. I have gathered a sample of people who were 50 or older and not retired as of 2017. I have merged individual and household survey variables, including mostly socio-demographic, such as age, gender, marital status, education, occupation, work experience, and etc., as well as household survey variables, which include, for example, family structure, information on debt, housing assets, and income. Here you can see a list of control variables which I have primarily used in my study, and the source in the database which I have used. I think I will not focus on them too much. More important are the variables of interest, which are the financial factors. Those are replacement rate, which I have estimated in 2 different ways. The first way is the fraction of pension income to total reported income, and the second way is the fraction of pension income to reported wage income. I must say that the replacement rate can be estimated directly only for those people who have transitioned to retirement between 2017 and 2021, because only these people have reported their pension income. So for people who have not retired in this period, the values for pension were calculated through the predictions, which were made via simple linear regression, where I have regressed the logarithm of pension on a number of individual specific variables, which include lagged logarithm of income, gender, dummy for rural area, year dummy, education level, and etc. So this is about the replacement rate, and there are also three other factors, which are income level, and I have used not the absolute income level, but the quartiles of income, which were calculated on the full sample of people and not just on the sample of interest of people who were older than 50 and not retired. And the two last variables are debt outstanding and house ownership. They were used as they were because they are just dummy variables of whether or not a person had outstanding credit debt and whether or not the person's family owns the house in which they are living. And as I have already said, my empirical strategy is the survival analysis, which I have made on a one record per unit sample. So for each individual in my sample, I had only one observation. For people who have retired, it was from the year of their retirement, and for people who haven't retired, the observations were from the last year of the observation period. I have estimated a number of model specifications, which firstly used control variables as well as all the financial variables, which is the first one. And in the second one, I have estimated models which only used financial variables, but I have estimated them on full sample and on subsamples, which were created based on the individual characteristics, which serve as control variables in the first model. So here, for the proxy of the COVID-19 impact, I have used the year dummy for 2020-2021 period. Now, briefly, the descriptive analysis of the sample in the age groups. The sample mostly consists of female respondents rather than male, mostly urban rather than living in rural areas, also mostly married than single. There is no consistency in the education level, as there are primarily mostly people who have graduated school, and people are equally divided between those who have completed either school, professional education, or higher education. And also there is an unbalance in the income level, because it is estimated on the full sample, and here we have only subsamples. So we see that mostly people were from high income quartiles, but with years, the fraction of people from lower quartiles increases as people here transition to retirement, which is often tied with the decrease in the amount of income. Also here we can see the employment status of the sample. So at the start there are no retired persons, and as we go to the 2021, the share of retired people gradually increases. However, we can also see the decrease in the number of observations, which indicates that some of the respondents somehow quit the survey. So it can be either for obvious reasons such as death or for some other reasons. Also, there is a descriptive analysis of the sample of newly retired, so of the people who have transitioned to retired in a particular year. And as we can see, with years, the mean age of people who transition to retirement increases. However, all other characteristics majorly coincide with those of the full sample. So mostly respondents are female, living in urban area, and are married. The education level composition also coincide with those of the full sample. However, there is a difference between the current and lagged income levels. So as we can see, for newly retired persons, current income levels are often lower, either first or second, while lagged income level quartiles are often third and fourth. So the most noticeable thing is that transition to retirement is tied with the decrease in the income level. Also, mostly retired persons have their house in ownership. They mostly do not have credit debt. They mostly do not provide help to children or grandchildren. There is a diverse composition in the occupations from which they retire. However, regarding the health status, mostly they have either average or poorer than average health. More important in the descriptive analysis part is the visual analysis, which is demonstrated by the Kaplan-Meier failure curves, which is a start of non-parametric survival analysis, and it shows the change in the hazard to retire with increase in age based on different individual characteristics. So for this slide, we can see the failure curves for people from different income groups, with 1 being the lowest income group and 4 being the highest income group. So as we can see from the graph, the failure curves are mostly distinct, and people from higher income groups often have lower hazards to retire than people from lower income groups, which may indicate that our hypothesis of income level having a negative impact on the retirement timing being true, which is yet to be seen in the regression estimate. Also, here we can see the failure curves by the debt outstanding, and here, as we can see, the failure curves mostly intersect, and there is no particular group which has either higher or lower hazard to retire. So based on this visual analysis, we cannot say whether having debt outstanding would induce or postpone retirement. The same is true for the variable of house ownership. So from the graphs, we cannot say whether owning a house would make you retire earlier or later. And now we turn to the main empirical part, which is the Cox proportional hazard regression estimates, which were done for every financial factor. So here we can see the results of the estimations of the simple model specification, which do not include control variables. And here the models are estimated on the full sample and on samples which are created by the corresponding individual characteristics such as gender, living area, education level, and income level. So for each sample, we can see that the number of observation as well as the number of failures or people who have transitioned to retirement are different. The main interpretation of the coefficient is that if the coefficient is more than 1, the factor is thought to be increasing the hazard to retire due to the exponential specification in this model. And if the coefficient is lower than 1, then the factor is thought to be decreasing the hazard to retire. Also, there are values of the proportional hazard test in these tables, which consider whether the assumption of the proportional hazard is satisfied or not. And given the significance level, if there are 3 stars, then the factor is significant at less than 1%. 2 stars, the factor is significant at 5%. 1 star is significant at 10%. And if there are no stars, then the factor is not significant. So here there are the results of the estimation for the replacement rate, which was calculated as a fraction of pension to total income. And mostly we can see that the results of the full sample and as well the samples based on gender and living area conclude that it has a positive impact on the hazard to retire, so it should induce retirement. As well as the interaction variable of the replacement rate and the dummy for 2020 shows that this positive impact is even higher in recent years. However, the dummy for 2020 itself has a negative impact on the hazard to retire. The opposite result, however, can be seen for samples by income level. For example, for first and second quartiles, we cannot see a significant impact of replacement rate itself, only of the interaction variable. And we can see that for third and fourth quartile, the impact is negative. However, the impact of the interaction variable is positive. And here we have a specification with a number of control variables, which are gender, living area, marital status, education level, health condition, occupation, and whether or not person helps to grandchildren. In the model 1, we do not include other financial variables, which are income level, debt outstanding, and house ownership. And in model 2, we include all the variables which are either control or financial ones. So based on the first model, we conclude that the replacement rate should have a positive impact on the hazard to retire, as well as this effect should be even higher in more recent years, while for the second model, we do not see a significant impact of replacement rate. However, the impact is significant and it induces retirement in the most recent years. We also have another specification for replacement rate, which was calculated as a fraction of pension to wage income. And here results are somewhat opposite to those which were for the replacement rate obtained as a fraction of pension to total income. And here mostly the impact of replacement rate itself is often negative for different samples, while the impact of the interaction variables is significantly positive. And as previously, the impact of the dummy is significant and negative for almost all of the samples. As previously, we also have two models here. The first one does not include financial variables, but includes control variables. And the model 2 includes all of the variables. Both models have similar results, and they indicate replacement rate having mostly significant negative impact, but significant positive impact in the 2020-21 years. Now moving on to income level. It was used as a categorical variable, so here we have the coefficients for the second, third, and fourth quartiles. The first model was estimated without other financial variables, but includes all the control variables, while models 2 and 3 include control and financial variables. Each model suggests that having a higher income quartile means a negative impact on the hazard to retire, which is consistent with our hypothesis that people from higher income groups retire later than those from low income groups. And also we can see that for model 1, there's mostly no impact or change in the impact of the income level in the recent years, while for models 2 and 3, the estimation indicates the positive impact of the income levels in the recent years. And the last two factors are debt outstanding. And for each of the models, estimated or either on full sample or in subsamples based on the control variables, we do not see any significant impact of having debt outstanding on the retirement timing or on the hazard to retire, as well as we cannot see this impact on the models which were estimated using also control variables and financial variables. And the same result is true for house ownership. So we can see a significant impact on the timing of the retirement, either on models which do not include control variables, and also in the models which include control and other financial variables. So mostly we have proved our hypothesis of retirement timing being impacted positively by the replacement rate only for the case if we estimate it as a fraction of pension income to the total income, and we do not prove this hypothesis if we look at the replacement rate as the fraction of pension to wage income. So we can see the inconsistency in the results given the estimation strategy of the replacement rate. So this can be added to the list of the limitations of the study, as well as the inclusion of the dummy for 2020-21 years can be an imperfect proxy of the COVID-19 effect. As it was showed in the work by Kapelushnikov, the postponement in retirement, which we have seen in the model estimations as the significant negative impact tied to the 2020 dummy, can be also attributed to the pension reform coming into act, especially in the recent years, because in the 2020 and 2021, the increase in the minimum eligibility age is not like 0.5 or 1.5 years, but 3 and more years. And also, as Ilyana Stanislavna has mentioned in her review of my work, the addition of spouse's occupation status can be significant in separating different factors impact on the retirement timing, as well as the estimation on another kind of sample. Here I have used one record per unit sample, where for each individual there was only one observation, but it is possible to have a sample which has a few number of observations for each individuals. So it includes observations for a number of years during the observation period. I think these are mostly the results of my study and the limitations on which I think I can work on and improve the results of the research. Now I'm open to your questions.
Thank you very much, Камилла. I fully agree with you. It's a real limitation that pension reform start in 2019, a year before COVID, and maybe you catch consequences not only COVID, but this reform. It's great that you understand this limitation, and I don't know how to split such effects. Maybe it's possible to find peoples, I don't know, maybe on military services or something like this, um, which retirement age is lower, and for them such pension reform doesn't matter, but I'm not quite sure that number of such cases, such observations was sufficient to perform such kind of research. I really don't know. Okay, and I'd like to add some technical remarks. Could you return to slide with your models? I don't remember exactly. Maybe 12. Yes, thank you. I guess in this model, X is a matrix of control variables, and pi, excuse me, rho is a vector of coefficients. Yes?
Yes.
Then you have wrong order. It's necessary to multiply matrix in the left and in the right row vector of coefficients. It is usual practice.
Yes, thank you.
And maybe the same remark for financial factors. Okay. And by the way, which retirement age do you use in your research? Or you use answer on the question whether you are retired or not? How do you?
Yes, I can comment.
Uh-huh.
For example, here there is a question J90, I guess, which states what is your current primary occupation?
Uh-huh.
So each of the individuals can report with from the list of the possible answers whether he is working, maternity leave, children care leave, not employed, and whether retired and not working. So here we consider retirement not tied to the age which is imposed by government, like 55 or 60 years, but rather than that, we say that the person is retired if he or she reports being retired and not working.
For example, as I know, for example, for artists of ballet in Большой theater, the retirement age something like 37, but maybe it's impossible to find such observations in your sample. I understand. Mm. Thank you. And how do you split people according their industries. Initially, you told about enormous number of industries, but after that, it was 9 or 10 industries. I don't remember exactly.
Oh, so here are not the industries, but rather the
Occupations.
occupations. Yeah.
Occupations, yes.
So these are by codes of whether some are managers or service workers and etc.
I see. And could you return to slide number 4? What do you mean by leisure? Why do you not include leisure in the first term, but you mean leisure only as time of pension?
Yes, so given the specification in these two models, they consider that the first period is fully dedicated to employment and the second to retirement. So there's like no time endowment for leisure in the period of employment. So all the time is only working, and the only source of utility is consumption. And in the period of retirement, there is a utility from leisure.
But we have plenty of people who are at the same time pensioner and at the same time they are working. So-called работающие пенсионеры. We have plenty, I guess we have many such people in Russia. Because the size of pension is very low, and if the health of so-called young pensioners is good, they usually work. At the same time, they are pensioners.
I think that this is more tied with the whether a person is employed, whether like the employment of elderly people, which is often considered in the papers, for example, most recent on working beyond the normal retirement age in urban China and Russia, where, for example, authors study these effects which impact whether a person is working while being a pensioner or not. So they definitely conclude that yes, people with better health or which are somewhat young, or if they are younger than 70, and mostly if they do not have an extended family, they are more prone to working beyond normal retirement age. But here we focus more on the effective timing of full retirement when a person is considered fully retired and when he or she does not combine these two.
I see.
Occupation.
Full retirement. I see. Please, other questions or comments?
Hello, I have questions. Could you please turn to the slider 30?
Can you
The
again the number?
slider 30.
13.
Yes. Actually, the question is about your data. Are you using the longitudinal data on the repeated cross-section data? Because I observed the simple size of your data is decreasing every year. So maybe the longitudinal data. Could you please explain why you made this choice?
So you're asking whether I use the longitudinal feature of the RLMS sample?
Yes, because I think maybe you use the longitudinal data.
Well, I am basing the sample on the data from RLMS, yes, but I do not have the panel data in the estimation procedure because I only have one observation for each individual which is in the sample, which is defined as people who are older than 50 and not retired as of 2017. And given their change in the employment status, I got the observations on either the first year and the year prior to their retirement, and for people who have not retired during the observation period, I only use the observations from the last year they are in this sample. So I guess your comment would be to include the possibility of the multiple failure events, which can be used in the survival analysis, and for two different type of failures, there can be two different hazard rates and impact of factors on these hazards. But I here focus only on one type of failure event, is the transition to retirement.
Okay,
I think your argument is correct, and maybe I should, in the further work, include this people who get out of the sample as, for example, another type of failure.
Yes. Another question is about the income level quantiles. How do you decide which the quantiles and individuals' income levels falls in to all ages, or the samples over the 50, or the only to the peers? Because we can find in IRV the quantile is not 25% equivalent. It's the 24, 90, 26, and the 31s. So I want
yes,
to know.
I've got the question. So you're asking why the composition between the income quartiles is not consistent with the definition of quartiles.
Yes, I use
So
comparative with all the people.
the income quartiles are estimated on the full sample of people which report the income in each year. So, and then these income quartiles, which were estimated on the full sample, there are some income quartiles for people who enter my sample of interest, and the composition is uneven. So people who are in my sample, they are mostly, for example, in the start of the year, they are mostly in third and fourth quartile because they are mostly working and maybe in some higher positions as they are experienced and etc.
Okay, I understand. Thank you.
Please, other questions, comments, remarks?
Camilla, thank you for your presentation. Great that you explained how you compose data and what is a feature of the model. Maybe you could make some bullet points about your main results. I would like to go to slides that show maybe the very first results on replacement rate to wage and replacement rate to income. And how would you explain the difference in the coefficients? What do they tell you? Because I see that replacement rate to income shows less robust results over subgroups, whereas replacement rate to wage shows quite robust results and pretty much modest coefficients. So what is the difference, and why do we see such difference?
I think one of the causes of the difference is the fact that wage income is less reported than total income in the survey. So as we can see, for example, the base sample for replacement rate based on income has 1,750, while in the next one it has less than, it has observations less by 100 or even more, and the number of failures is less by 100 observations. But if talking intuitively, maybe there is the impact of why the different kind of income, the total or wage income, is reported or not. However, it is more close to the problem sample selection bias.
Do you say that you have many observations with income reported, but much less observations with wage, and because of that, you think that the results that to me are more reliable, actually, the second one, are less reliable? To me, they are more reliable because they are robust over estimates. Here we see quite a jump in coefficients. Taking this 7.11 for no school people.
Well, I think that by education level, there is also a reason of that the samples itself are rather small for people who have no school and those who have either school, professional, or higher education.
Thank you. And it seems that for male, which is unexpected, now I look at failures, that male were more like people who survived compared to women, or maybe I am wrong. It's more than, it's say 55% of women died let's say retired, sorry, retired. And well, no more than 30% of men retired in the observed period. Is it what you find in descriptive statistics as well?
Yes, mostly retired are female. However, the mostly respondents are also female. However, the extended results of the regression estimates, which include the control variables, report that gender has a significant negative impact on the hazard to retire, with the gender being a dummy variable, where one indicates that the person is male, and it is consistent with the findings of existing literature, which suggests that male often retire later than women.
Yes. I forgot that we have a 5-year difference. So this 5-year difference in eligibility to retire is what we see in data for men and women. So maybe this is just as given. Okay. Well, I think it would be good to put some main results into one slide to make them strong enough to see the contribution of the research into the area.
Yes, okay. Thank you for the comment.
Thank you, Lena Stanislavna. Other questions, remarks, proposals, how to improve this presentation? Okay, if we have no other comments or questions, really many thanks to Camilla for so interesting presentation. And I guess we could make usual joint photo. Thank you.